Welcome to my math presentation. Today I'm going to show you the beauty of math, but I'm also going to show you that math can be tricky if you are not careful enough. I called my presentation Straying into Absurdity 2 is equal to 1. My presentation is a classic demonstration of how easy it is to start off with a very simple statement and then, within a few apparently straightforward and logical steps, please remember, I'm going to use only logical steps, and I'm going to prove you that 2 equals 1. Are you ready? Okay, let me start. First, let's begin with this beautiful, simple statement. A is equal to B. Why A and B? I like these letters. You may use X and Z, P and Q. Alphabet has many letters, so choose what you want. I like A and B. But come back to the proof. In my statement, there is an equal sign, so I may call it also an equation. Because this is an equation, I can multiply both sides of my equation by any number. I chose A. And I receive A times A equals A times B. Of course, you may write in a simple form the left side as A squared, but for a while let's leave A times A. Then I'm going to add to both sides this expression, A squared minus 2AB. This is what I receive. A squared plus A squared minus 2AB is equal to AB plus A squared minus 2AB. If you know the simple rules of algebraic expressions, you know that I may simplify both sides of my equation. So I received 2 times A squared minus AB equals A squared minus AB. Have you noticed something interesting? Both sides of my equation have the same expression, A squared minus AB. And if both sides of my equation has the same expression, of course, I may divide by it. So let's do it. Let's divide by A squared minus AB. And this is what I receive. 2 is equal to 1. Yeah, I wanted to receive it, and I have. But, unfortunately in math, it is not true. Because 2 is not equal to 1. The original statement appears to be and is completely harmless. But somewhere, in the step-by-step manipulation of the equation, there was a subtle but disastrous error, which leads to the contradiction in the final statement. Let's analyze from the beginning. We know that we have the simple statement A is equal to B. And we also know that we may multiply both sides of my equation by any number. By 2, by 5, by 10, any number will work. And the set of solutions of the second equation is the same as the set of solutions of the first equation, so my equations are equivalent to each other. So my first step is true. Then, of course, I may add any number to both sides of my equation, and again, the set of solutions of this third equation is the same as set of solutions of my second equation. So my third equation is equivalent to the second one. And the second equation was equivalent to the first one. It means that my third equation is equivalent to my first equation because they have the same set of solutions. The next step is only simplifying my equation, so nothing interesting has happened. But here I have a division. And please be careful, division is very tricky. I have a squared minus ab. Do you see something interesting in my proof? What do you think about this second equation? Let's write it in a different way, as a squared equals a times b. It means that a squared minus ab is equal to 0. So, in the third step, when I divided by a squared minus ab, it means that I divided by 0. And unfortunately, I cannot, because division by 0 doesn't work. It's undefined. I cannot do it. But I did it. And here is my trick. Dividing anything by 0 is a risky step, because 0 will go into any finite quantity an infinite number of times. By creating infinity on both sides, we have effectively torn apart both halves of the equation and allowed the contradiction to creep into the argument. This subtle error is typical, and very mathematicians were caught by it. I tried to show you that 2 is equal to 1, but unfortunately I did something wrong. I divided by 0. And please remember, never divide by 0. Unfortunately, division by 0 doesn't work. It's undefined, and you cannot do it. As I said earlier, many mathematicians were caught by this division. So anytime when you are going to divide by any algebraic expression, please check if your expression isn't 0. If your expression gives you any different number, let's do it. You may divide by any number, but no by 0. Sorry, I tried to trick you and have fun, but I proved that sometimes something that looks harmless, and as I said at the beginning, I used only logical steps, and I could do everything with my equations, but I cannot divide by 0. Please remember, and please be careful. That's why I love math. It's beautiful, but you must be careful. Don't divide by 0. Thank you.